Hello students, welcome to the quick solutions of All India Cast Test Series Medical 2019 Test 6 Code A and B Physics. The test date was 20th January 2019. Let's start with question number 1. In question number 1 it says that if gravitational potential at a point xyz in space is given by Vg is equal to minus gm 1 by 2x plus x by y square plus 1 by z, then x component of gravitational field intensity at 1, 1, 1 is. All quantities are in SI unit. So according to the question, gravitational potential is given and we have to calculate the gravitational field intensity, but only the x component. And we know that the gravitational field intensity along x-axis can be found by using the potential gradient along x-axis, that means minus dv by dx, but assuming y and z as a constant, right? So whenever we want to find the gravitational field intensity along one of the axes, then other two coordinates are assumed to be constant, right? So the potential is given, we have to differentiate it with respect to the x, keeping y and z constant to find the gravitational field intensity. So if I differentiate the given gravitational potential, we will get minus d by dx of minus gm 1 by 2x plus x by y square plus 1 by z, right? Since gm is a constant, so it will come out of differentiation, and this is a minus and this is a minus, so it will become plus. So gm d by dx, the remaining thing will remain inside, that will be 1 by 2x plus x upon y square plus 1 by z, right? So if I use the addition rule of differentiation, so according to that we can write gm d by dx of 1 by 2x plus d by dx of x by y square plus d by dx of 1 by z. We are using the addition rule of differentiation. And since y and z is a constant, so we can see here this is a y and this is a z, so it will remain constant. So this whole differentiation will become 0, right? Only these two will remain. And what is the differentiation of 1 by x? So we know that the differentiation of 1 by x is minus 1 by x square. So you will get gm minus 1 by 2x square, right? And x by y square, differentiation of x by y square, since y square is a constant, so it will remain as it is, and the differentiation of x is 1, so you will get 1 upon y square. So this is the gravitational field intensity along x-axis, but we have to find the gravitational field intensity at 1, 1, 1. So if I put the value of 1, x is equal to 1, y is equal to 1 and z is equal to 1. So you will get the gravitational field intensity Ix will be equal to gm minus 1 by 2 into 1 square plus 1 by 1 square. So by solving this, you will get gm by 2. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 2. In question number 2, it says that a satellite of mass m0 is revolving around the earth in a circular orbit at a height of 3r from surface of earth. The aerial velocity of satellite is. So according to the Kepler's second law, we know that the aerial velocity, that means area swept by the radius vector per unit time, will always be constant, and that will be equal to the magnitude of the angular momentum by 2m0. So this is the formula of the aerial velocity we know from Kepler's second law, right? So we just need to find the angular momentum of the particle, and we know that the angular momentum of the particle, magnitude of angular momentum, can be written as simply mvr, where v is the velocity or you can say speed, magnitude since we are calculating the speed, and r is the distance from the center. So according to the question, the satellite mass m0 is revolving around the earth in a circular orbit, and we know that if a satellite is moving in a circular orbit, then its velocity, that means orbital velocity, will be given by root under gm, where m is the mass of the earth, divided by the distance from the center. So distance from the center can be written as r plus h, where h is the height from the surface. So this will give you root under gme upon r, and since the height is 3r, so we can write plus 3r. So you will get 1 by 2 root under gme by r. This is our orbital velocity or speed of satellite, right? So now we know the velocity. And what is the distance? So distance is r plus h, that means 4r, h is 3r, right? So we know the distance, we know the velocity, we know the mass. Now if I put the values here, so we can say that our angular momentum will be equal to m v naught r, that means m 1 by 2 root under gme by r into 4r. So that means 2m into root under gme r. So this is our angular momentum. So if I put the values in this formula, that is aerial velocity will be equal to 2m root under gme r divided by 2m. So 2m will cancel out. So you will get root under gme r. And since mass of the earth is constant, radius of the earth is constant, so as you can see that the aerial velocity becomes constant. That is the Kepler's second law. So the option number 2 will be our correct choice. Let's move to the question number 3. Question number 3, it says that which one of the following is incorrect statement about gravitational force. So we know there is 4 kind of force: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So in these all 4, the weakest is gravitational force. So this is our true statement. Second statement says that gravitational force between 2 point masses is independent of medium in which point masses are placed. Yes, this is also true. We know this from the Newton's law of gravitational force, right? It does not depend on the medium. Third statement says that it obeys principle of superposition. Yes, we know that we can add the gravitational force simply by using vector addition, right? So this is our principle of superposition. Fourth statement says it is a non-conservative force. No, this is the false statement because gravitational force is a conservative force. So our option number 4 will be the correct choice. Let's move to the question number 4. Question number 4, it says that a point mass m is placed on the surface of a hypothetical planet where acceleration due to gravity is g by 2, where g is acceleration due to gravity at the poles of planet. The latitude of that position is, we know that when Earth or any planet rotates, then the acceleration due to gravity at equator, at pole, at any longitude will be different. And that formula is given by g apparent will be equal to the acceleration due to gravity at pole minus omega square r cos square lambda, where lambda is the latitude. So according to the question says that the g is acceleration due to gravity at the poles of planet. So this is g. And what about omega? Question says that t is the time period of the planet. So we know that omega can be written as 2 pi by t. So we can write 2 pi by t whole square into r cos square lambda. But according to the question, it says that acceleration due to gravity at that point is g by 2. So that means the apparent acceleration is g by 2. So when you will solve this, you will get minus g by 2 is equal to 4 pi square by t square r cos square lambda. So when you will solve it, you will get g by 2 will be equal to 4 pi square r by t square cos square lambda. So cos square lambda will be equal to gt square divided by 8 pi square r. So from here we can say that cos lambda will be equal to square root of gt square upon 8 pi square r. So lambda will be equal to cos inverse gt square upon 8 pi square r. So we can say that our option number 2 will be the correct choice. Now let's move to the question number 5. In question number 5 it says that the forces between two identical particles separated by distance d is F. Since there is an identical particle, so the masses will remain same. So let's assume that mass is small m. So according to the question, if there is a two mass m, the distance is d, so the gravitational force between these two particles will be how much? G m by d square. But according to the question, this force is given by F. So that means F is equal to G m square by d square. This is our F. Now question says 4 such identical particles are placed at the corners of a square of side d. So let's say there is a square of side length d, and the 4 such identical particles are placed at the corners. So every corner there is a particle of mass m. So the magnitude of net force on any particle. So let's say we want to calculate the force. So let's say that we want to calculate the force on this particle m. So forces on m will be due to 3 other particles. Due to this particle, it will be in this direction. Due to this particle, it will be in this direction. And due to this particle, it will be in this direction. So let's call it this force F1, this force F2, and this force F3. So we know that the magnitude of F1 and magnitude of F2 will be same. Why? Because the masses are identical and the distance is same, and that will be equal to G into m by d square, and we know that according to the question this is equal to F. So we can say that F2 will be F and F1 will also be equal to F. Now what about F3? So magnitude of F3 will be how much? So magnitude of F3 will be equal to G into m by root 2d whole square, because the length of the diagonal will be root 2d. So that will be root 2d square. So we can write it G m into m by 2d square. So that means it will be equal to F by 2 according to the question. So we know all the forces, but we have to calculate the magnitude of the net force. So first, if I find the magnitude of F1 plus F2, since they are perpendicular to each other, so their vector sum will be simply F square plus F square. That will give you root 2F, right? And what will be the resultant of these two forces, F1 and F2? So we know that the resultant of F1 and F2 will be in this direction. This will be the direction of the resultant of F1 and F2. Since they are perpendicular and equal, so the resultant will be along the bisector. So this will be our magnitude of F1 and F2. So the magnitude of the net force will be simply equal to the magnitude of F1 plus F2 and the magnitude of F3, because F1 plus F2 will be in the direction of F3. So they will be simply added. So that will give you root 2F plus F by 2. So that will give you 2 root 2 plus 1 by 2 whole into F. So from this we can say that our option number 3 will be the correct choice. Now let's move to the question number 6.